Depending on the kind of software you build, it might be simple and it might be complex. So let's say you make your application, it's working fine, and you have some customers. Your customers go from 100 to 1,000 to a million, and it will get to a point where your servers will not be able to handle the load. And that is exactly what we are going to be talking about in this video. Given that you now have plenty customers, let's say you have a simple architecture like this. You have several users that are communicating with a single server. But when you start to get lots of requests from these users, say you have a million users now, you are getting a lot of requests to this server and the server cannot handle it anymore. What you need to do is to increase your capacity to handle different requests. Since you've gotten to the point where you need to scale, there are several ways you can go about this. You can either vertically scale or horizontally scale. So let's talk about vertically scaling. So vertically scaling is basically increasing the capacity of your server. Now, this server itself has 4 gigabytes of memory and it only has one vCPU. So what you can do is to increase this to 8 gigabytes and this to 4. Okay, let's say 4 vCPU, and let's assume that this is bigger, so we have a more robust server. So you have successfully vertically scaled your application. But at this point, there's so much a single server can handle, and vertically scaling might not be enough. So what you might want to do now is to horizontally scale. Horizontal scaling means to increase the number of servers that you have. So you literally be horizontally adding this to your architecture. But then we have an issue now. How are users going to know the exact server that they are supposed to communicate with? Okay, so in this case, we might need to adjust the way we do things. So let's start all over. We have multiple users communicating with a single server, and we want multiple servers. So instead of the users communicating with this server directly, let's introduce a reverse proxy. If you need more knowledge about proxy, to be linked above. So now we are going to introduce this server, which is a reverse proxy, and we would call it our load balancer, because in this case its only use is just to distribute load between our several servers. So we have this server 1, then let's assume that we are horizontally scaling and we are having like 3 servers here. So the load balancer itself will have some strategy to distribute the load coming from it, and our users don't have to worry about which server they are communicating with. They just know they are communicating with this load balancer, and our diagram is basically going to be this. So the strategy of this load balancer here, this reverse proxy distributing load to these 3 servers, is known as load balancing. Now that we have several servers and a single load balancer, we need a strategy to distribute the load amongst these servers, hence balancing the load. A simple thing we can do is just to randomly distribute the load. When a request comes, we just randomly pick a server and throw the request at it. Another strategy we might want to use is the round robin strategy. So let's say we have this server A, server B, and server C. So in the round robin approach, what you do is you send the request to the servers one after the other. When request 1 comes in, it sends it to server A. When the next request comes in, it sends it to server B. When the next request comes in, it goes to server C and it starts all over. Then to server A, to server B, to server C. And this is the round robin approach. But let's assume a scenario where your servers don't have the same capacity. So for instance, let's say this server C, it only has 4 gigabytes of memory and 2 vCPU. In this scenario, server A and server B are twice as powerful as server C. We can use a weighted round robin approach. So here we can say when the first request comes in, it goes to A, the second one goes to A, so we have 2 going to A. Then we can also say 2 will go to B and 1 will go to C. So we just start all over. So we'll have something like A, then A. Let me make this bigger. Okay, so the first request goes to A, to B, then to C, then it starts all over. A, B, B, C, etc. So this is the weighted round robin approach. Another approach would be using a least connection approach. So we are going to check the server A to C and see the one that has least connection. But because of how this is fashioned, the load balancer needs to know the state of all the machines. In this approach, we can have the load. Let's say this is the load balancer state. Load balancer. So it will keep track of the amount of connection that is going to server A, server B, and server C. Let's say at a point in time, server A has 20 requests, 20 connections. Then server B has 10 connections, and server C also has 10 connections. So what the load balancer would do would be to check the servers and see the one that has the least amount of connection, which will be the first one will be server B here, and it will just send request to server B, and then we'll have 11 here. So on the next request, we can go to server C, and let's say before we go to server C, some requests have dropped from here, and maybe 11 requests have dropped from here. Then the next request will be saved to server A. So this is called the least connection strategy. Before we move forward, let's talk a little about how we measure the amount of load on a particular server. So far, what we've been using to measure the amount of load on a server is the number of connections or the number of requests to that particular server. But another way to measure it would be the amount of resource that particular server is consuming. And this is important because all requests don't consume the same amount of resource when they are being processed. Say you are trying to get the authenticated data of a particular user. The request shouldn't take as much resource as compared to you converting a file to another kind of type of file. This kind of request will take longer time and more resources. Another way to measure the amount of load on a particular server would be to actually measure the amount of resource that is being used. So we can measure it in percentage. So for this server A, for instance, if it starts using 4 GB out of its memory, we can say it's using 50% of its resource. Okay, we can track this resource on different servers and use it to know which server we are going to route a particular request to. So as we said in the previous strategy, which is the least connection strategy, in this case also we are going to be measuring the metrics of each server. In the load balancer itself, we'll be tracking the resource that each server is using. So server A can be using 20% of CPU, and server B can be using more. So let's say server B is using 50% of its CPU and server C is using 80%. So once a request gets to the load balancer, it will go through the servers and see that server A is using the least amount of resource and route that particular request to that particular server. So now that we've established that we can route based on resource usage, we can also try to reduce the amount of resource that we are using in the first place. So let's say we have two requests, request A and request B. Where request A is going to use lesser resource as compared to request B, and request A will also take a shorter amount of time. So what we can do to reduce the amount of resources that we are using on the server would be, after we've completed this request B, which is actually heavy and it takes more time to process, we can save the data so that if the user requests for that particular resource or wants to process a similar request to request B, we can just take that saved data and send it to the user. So in this case, let's say user A, okay, this particular user, let me say it's yellow. Okay, this particular user sends request B, and request B goes through the load balancer, and after the load balancer has done its computation, it says server A should handle the request B. Server A took about, let's say, 1 second to process this particular request, but since it doesn't want the request B to be computed again, it saves it. So server A saves this request and puts it in memory, hoping that when this user makes that particular request again, it can just give it the saved data. And by doing this, you can improve the latency of the system, i.e. reducing the length of time to respond to this particular user, and also reduce the amount of memory that is being used to process this request. But then, how do we know that this request B is going to come to this server? Because in a future time when this user is making this request, that's this request B, the load balancer can determine that the next available server is this server B, and it will transfer this request to the server B, and server B will have to do the computation all over again and saving a copy of request B and responding to the user, hoping that the user is going to send another request. And we can see how this is going to easily become a problem, which means we need a strategy to process a user's request and also be able to route that particular user to the same server in the future so that they can access the saved data on that particular server. Okay, to do this, we can take some details from this user. Let's say the user's IP address, for instance, which we know is supposed to be constant for this particular user. So we would hash this user's IP address, then put it through the load balancer. Then the load balancer would map that particular hash to a server. Okay, let's describe a hashing function. The hashing function is a particular function that is going to take in the IP address. In this case anyway, it's going to take in the IP address and map it to a number output. So it's going to map it to a number output. Okay, so we have this simple process, and the load balancer does this hashing itself. So once it receives a request from the user, it gets the IP address for this user, which is here, passes it through a hashing function, and it will get the hash for that particular IP address. So this hash is going to be mapped to a particular IP address. So in this way, we can ensure that a particular user's IP will be mapped to a particular server. And this strategy itself is called the hashing strategy. Thank you for watching this video. You can like and subscribe to this video if you want to be seeing content like this. And also, if you have a particular concept in mind that you need explanation to, or a simple way to understand it, you can leave it down in the comments below. Thank you. Happy coding. Bye.